Alright, so the basic breakthrough for me was tracking the holes differently than the actual memory, and the allocations different than the memory, so I'll show you. Define the header class based on what they wanted, put the best fit and worst fit here, but then I defined in the actual CBP file. So first thing, I defined a mem block, which will take care of our holes and allocations, occupied, offset, size, address, and so I have a vector that will have a continuous full mem block of these holes and allocations, and I have these ints free index and allocate index to help me traverse, and then a byte array of memory. And so when we construct the memory manager, just set the word size allocator. When we clear the block, the full mem block vector. And initially here, this is where I was freeing memory. Later I used SBRK, so I didn't need it. Get word size, pretty simple. Set allocator just sets it, setters and getters. Initialize, we check the size and words is correct. Then we get the total bytes based on size and words times the current word size. That's the same as a mem limit. And then we allocate memory with SBRK, which just moves a data segment. So no need to use malloc. And so then we create the initial memory block, which is unoccupied, offset 0, size and words, and has that same address in memory. We insert it and update free index. When we shut down, we have to clear that vector similarly to when we destruct, and we reset the globals. So get list, which is used in allocate, I will show you, returns a whole list and just defines a number of elements being free index plus 1, because the first index will be the number of holes, which is the same as free index, and so this is the pointer to that. We later have to delete it in allocate, and so we iterate through and respectively add offsets and size. In allocate, we get that get list, check the size in bytes is correct, is it divisible, cool. Okay, then we get the allocate offset in the allocator function, and so these come into best fit or worst fit. Best fit being right here, pretty simple. We get the smallest hole size being int max was first and the current hole size, and we iterate through the holes. Alright, cool. Is the size in words less than the current hole size? Okay, cool. Is it smaller than the smallest hole? Then we reset the smallest hole, set the word size, and return that. Worst fit is similar but opposite, and so biggest, and then check it's greater than. Cool. So we're back in allocate, and we have an allocate offset. It's not -1. We continue. It's unoccupied. The allocate offset equals this. Do we have to replace it fully because the size is equal to size in words? Okay, cool. We take that into consideration. Create the mem block. And so we replace fully, we have to adjust free index. If not, we just adjust the next block to have the size correct and all that. And then we go through the memory block and reset the memory to 1 based on the allocate offset and size in bytes. And then we delete that. And so free is similar where it takes an address. It's not no pointer. Okay, cool. We can continue. Go through the memory block. Is the address equal to address? Cool, we're there. Then we need to see the previous block and the next block. Are they holes? Alright, if they are and they're both holes left and right, we have to absorb them, and this does that. Only the left is a hole and then the right is a hole. Otherwise it's just an allocation. And it needs to be free. Then we erase, reinsert, fix the indexes, and then we reallocate the memory or reset the memory from those bytes from that offset to 0. Dump memory map is similar to get list, except it writes it to a file, and so this is where it does that. It gets the buffer, copies, open, write, pretty simple, deletes the buffers in the list entry, same as get list. Get bitmap is similar in that it traverses through and creates the bitmap for it. So first I needed to reverse the bitmap, then I got the number of bytes. Based on that number of bytes, I set the first data segment to that number, little endian, and the second data set to the other set of bytes. I pushed it onto the vector, and those are the size. And so when we return this, it's actually a int pointer with the number of bytes needed plus 2, because the first two are the size, which is data 0 and data 1. We iterate through. I created a bit string of it, then it had it to a string, and then I got the value of the int, kind of roundabout, but it worked. Not my best code. However, it passes test and get memory start, just returns memory, get memory limit. And so if I show you guys, this is my testing, and obviously it didn't always work like this. Oh. And so when I was testing before, or as I was going along, I had my own testing functions. Look at that, bloop, 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 no freeze, cool. I would go in here and literally just comment out these and go one by one. And so I had like 19 out of 38, and then eventually got 38. So yeah, this was that project, and it was really hard, but we did it. Make file pretty simple, blah, blah, blah.